Hello, everyone. Welcome to our presentation. Today, we will be discussing our research, violence detection on social media using machine learning. And allow us to introduce ourselves. My name is Gabriela Saenz. I am a computer science student at UT Dallas, and my research interests include artificial intelligence and machine learning, social good computing, and STEM education.
Hi everyone, my name is Lisa DiSalvo. I am a rising senior at Arcadia University. I am currently a computer science major with interests in UI, data science, and social good computing. Thank you.
The problem that we focused on in our research is safety on social media. In today's day and age, social media has become a ubiquitous force for positive change, community building, and sharing ideas. But with billions of people of all ages tuned into social media, many hazards and mishaps can arise due to inadequate content monitoring. Therefore, our research problem deals with social media safety practices, flagging sensitive posts, and effective content monitoring. Content monitoring on social media comes with several potential mishaps and hazards, and we found that these three were the most important and impactful. First, incorrect flagging. Incorrect flagging occurs when a social media platform uses their built-in machine learning model to flag posts. Flagging consists of either marking a post with a content warning before allowing users to opt into viewing the sensitive material, essentially putting a partial censor on it, or fully censoring it by removing a post from the site entirely. Typically, justifications for flagging fall under the categories of violence, hate speech, or bullying and harassment. If a post is flagged incorrectly, meaning the post is harmless, content is taken down from the site without need, and resources are wasted on this effort. Alternatively, real harmful posts are allowed to remain on the site. When harmful posts stay up on social media, a threat is posed to public safety, either deriving from the post itself and the claims made by its writer, or from the spread of misinformation. Although social media fosters many positive spaces, it is often a tool used by violent perpetrators to incite fear in potential victims, individuals or large groups of people, or to warn against a forthcoming crime they plan to commit. If these posts go undetected, public safety is put at severe risk in the real world, not just in the cyber world. One way to combat these issues is the positive communities that are built on popular platforms such as Twitter, Instagram, and Facebook. Local news is no longer only shared on the TV or the radio. For example, regional weather channels may post on Twitter to update their communities on potential severe weather so they can get to a safe place before it comes. And police departments may post on Facebook to let everyone know about an area they should avoid when driving due to a dangerous traffic accident. However, those in severe circumstances like these cannot get the help they need if they are clouded with misinformation. Misinformation is shared en masse online, and in the cases of violent acts, local breaking news, or natural disasters, users need to be able to discern accurate from inaccurate information. The safety practices from content monitoring tools need to be able to perform these tasks. Social Sentinel is a prime example of a rising social media content monitoring tool from the self-named company. Social Sentinel sells their software specifically to schools, typically high schools and middle schools with young social media users aged 10 to 18. Schools then use the software to monitor their students' social media. The hope in monitoring their content is to protect them from unnoticed signs of poor mental health, the possibility of self-harm, or harm to others, and then provide them the needed counseling at school to prevent these behaviors. However, most teams have an online presence across multiple platforms, and Social Sentinel only monitors one platform at a time. So while a school feels students are safe based on their Twitter posts, for example, they could be missing a completely different side of that student on their Instagram posts. If a school wanted to monitor multiple platforms, they would have to take on additional charges from Social Sentinel, put in more resources, and waste more time going through each platform one at a time. In order to effectively prevent social media software mishaps, there needs to be a way to gather and monitor large amounts of social media posts at once across various platforms.
Our solution to this issue involves creating a web scraper that utilizes machine learning methods to go ahead and analyze posts from social media websites. So our program is called Violence Detector. It scrapes Twitter posts with certain dates and can focus into specific hashtags. Found tweets are then loaded into a CSV file, and on the right you can see the user interface of our program. And there's our video. We have a video to show you that demonstrates the program. Hey, welcome to the Violence Tester demo overview. Our app essentially goes over tweets that we have scraped using the libraries Twint and Tweetbee and goes ahead and detects them whether they are violent or not according to our pre-written corpus of pre-established violent or sensitive terms. We also use Violence Detector, which is another library from GitHub that manually labels using CSV2, manually labels images, specifically the images we are pulling from the Twitter API based on what is in the image, and it mainly looks for violent images. For example, it labels things like fire, fighting, and any type of violence, car crashes, etc. To begin, you can see we have our imports and then we have our consumer key, access key. These are used in order to access the Twitter APIs, and they are generated through your user account. You have to apply it actually to be able to access Twitter scraping, and you get these keys after applying and being accepted. We use PySimple GUI as our GUI interface in order to make things look very simple and clean. So to begin, we have our first function. It's the search CSV function. This is a simple function that calls upon our corpus to search through, and you can see that this actually is using the twin images from the CSV file that we intend to have image links to then point to the image from the link, and we're using the violence detection library to filter images. Currently it is a work in progress, but in order for this to work moving forward, we must download images from the CSV file. Then specifically we have to download the image links, store in a local folder, and then have a loop to iterate through each image in folder, and then the library would label the image based on this. Then we have our print tweet data. This is works with the scrape function. It just showcases what a tweet, username, description, all the details in the output, just so that we know that the function is working. And then we have our scrape function, which looks for all those details you saw above: tweet, username, follower count, total tweets, hashtags, and etc. And then we have our table. This is just to showcase a table of the CSV file outputted by the scrape function in our GUI. And then we have our scrape images, which is to use by Twint in order to grab images from Twitter, along with other information, the other information that the scrape function also finds as well. And then here we have our layout, which is basically how the GUI works. It's a container, and you just go ahead and insert buttons, text, and it's very easy and user friendly. And then we have our event handler to run the functions upon pressing buttons in the GUI. So for example, here is what our program looks like at the moment. Violence detector, the easy way to detect violent posts. So our search for posts at the moment is through tag and date. So let's look up posts involving COVID-19. So we have 2021-02-02 COVID-19, and it has to be in this format. And so we can go ahead and press scrape posts, and it'll give you this output, which I'm just going to hit OK, and it takes a moment. And then you can see here, done, and the posts are all scraped. You can also see the output CSV file. So this is our scraped tweets file that we just did, and you can see we're looking to have our program run in a loop. Since it is a work in progress, it doesn't run in a loop, so when you exit out, it kills the kernel. And you can see here it has a little error. Along with outputting our tweets that we scrape this using Tweepy, we can also scrape using images. So for example, we would scrape with the same search terms, 2021-02-02, COVID-19. You hit the scrape image button, and you can see that we have our output. And there are some errors here, but I can rest assured that we do have that output. So here is our image file that was just created. And here we have each image, and it outputs all that information that is also outputted with the tweet scraping. But this one specifically focuses on the parameters that we established in our code, which are specifically media links. So we have our PBS media. Let's go ahead and take a look at that in our browser. You can see here, random image from a tweet. And then, for example, do another one just to make sure that there are no errors in what we're scraping. Here's another image. This one must be from the same tweet, it looks like. And then we have our cancel button, which essentially cancels the program, exits it. And then we have our detect violent posts and detect image buttons, which are currently a work in progress, but eventually we are looking to use the violence detection library, which is with this function, in order to go ahead and go through those individual links and label those tweets. And we can easily label those the text within the tweets with this search function. However, our search list would be comprising of our corpus, which we have in a CSV file that we just have to append to this function. However, as you can see, it is still a work in progress, but they are curated and just need improvement upon the existing code. So that is our app at the moment, and we are looking to expand this past Twitter and make it easy in order for all research students to be able to scrape not only Twitter, but apps like Facebook, Instagram, and so on. Okay, so moving forward from that, our future timeline involves finalizing our violence detector program to scan images with posts as mentioned in the video. Secondly, we're looking to expand to additional social media platforms, Instagram, Facebook, etc. Then we're looking to analyze our machine learning model and make necessary improvements. From there, we'll begin software testing from data across multiple platforms. And then finally, improve on the UI/UX of our easy to use scraper. And then finally, complete our scraper and machine learning tool that works across multiple platforms. Thank you. Any questions, you can find us at the following emails.